Now I'm going to discuss about lasers. Lasers, basic concept of a laser. What is laser? What is the speciality of laser compared with ordinary light? First, we need to discuss about what is laser. Laser is an abbreviation of light amplification by stimulated emission of radiation. What is meant by that? Laser, L stands for light, A stands for amplification, S stands for stimulated. There are two kinds of process. First one is spontaneous emission process, the other one is stimulated emission process. The laser follows stimulated emission process. E for emission and R for radiation. Light amplification by stimulated emission of radiation. To produce a laser beam, we need a stimulated emission process. Okay, and laser first introduced by Dr. Th. Neumann in 1960, and the necessary theory was given by the Albert Einstein. Albert Einstein. What is the basic mechanism behind a laser? To produce a laser, what are the necessary theory which you have to follow? What are the important relations we need to discuss? Okay, first we will discuss about special characteristics of laser compared with ordinary light. There are four characteristics. The first one is high directionality. High directionality. Compare with ordinary light, a laser having high directionality. What is mean by that? For example, an ordinary light source traveling a distance 1 meter to reach a target. Okay? During the traveling, the angular spread of the ordinary light is 1 meter. For 1 meter distance, the angular spread of the ordinary light is 1 meter. Whereas, in case of laser, for 1 meter, the same distance to reach the target, the angular spread of the laser is just 1 millimeter, the angular spread. So, it can travel longer distance without much loss of energy. That is one of the advantages of laser, high directionality. The next one is high intensity. High intensity. High intensity. As we discussed here, high directionality, before reaching the target, the angular spread is lesser in case of a laser beam. Because of less angular distribution, the less loss of energy before reaching the target. So, high intensive. The laser is highly intensive as compared with ordinary light. Next, the third one. The third one is monochromaticity. Monochromaticity. What is meant by monochromaticity? A source which is having only single wavelength or single frequency called as a monochromatic light or called as monochromaticity. Having single wavelength. Okay? If you compare with the ordinary light, a laser having a single wavelength, almost a single wavelength. Okay, whereas ordinary light having almost all the spectrum, all electromagnetic spectrum it contains. So, next one is coherence. The next characteristics of the laser is coherence. First, what is mean by coherence? What are the conditions to be satisfied to be a coherent source or to be a coherent light? The first condition is the light source should produce single wavelength. Should produce single wavelength. Single wavelength. Next property is the light waves which are having same amplitude. Same amplitude. Same amplitude. The next property, third property is the light waves which are producing from the source should be in the same phase or constant phase difference. That is another property. The same phase or in phase or constant phase difference. Constant phase difference. These are the three properties to be satisfied to be a coherent waves or to be a coherent light source. Okay, these are the special characteristics of a laser beam when we compare with the ordinary light source. Then interaction of light with matter. Next, interaction of light with matter. Interaction of light with matter. How what happens when light interacts with the atoms? What are the quantum process that takes place inside the matter when light interacts with atoms? The first process, the quantum process which takes place is the absorption process. Absorption process. The second one is spontaneous emission process. Spontaneous emission process. The third one is stimulated emission process. These are the three processes which takes place inside a laser medium. To produce a laser, we need to understand these three basic processes. The first one is absorption process. What is meant by that? For example, consider a low energy ground energy state E1 and excited energy state E2. Okay, in the ground state there are n number of atoms. In the excited state there are n2 number of atoms. Okay, first look at the ground state. Okay, there are so many atoms in the ground state. Okay, when light is absorbed by an atom, it goes to the excited state. The atom will go to the excited state. So many atoms will go to the excited state by absorbing the photon energy or electromagnetic radiation. Go to the excited state. Okay, and then what is happening to the excited atoms? This is called absorption process. Next, what is happening to the atoms which are there in the excited state? The second one is spontaneous emission process. What is meant by spontaneous emission process? E1, E2, N1, N2. Okay, there are some number of atoms in the excited state which absorb the photon energy and then they come back to the ground state by itself after 10 to the power of minus 9 seconds. After 1 nanosecond, it comes back to the ground state by releasing the absorbed photon. They are coming back to the ground state by itself without any external agent, which is called spontaneous emission process. And this 10 to the power minus 9 second is the average lifetime of an excited atom. Okay, the next one is stimulated emission process. What is meant by stimulated emission process? E1, E2, N1, N2. Okay, there are n2 number of atoms in the excited state. Okay, now what is happening to this? Here there are n number of atoms. The lifetime of the excited atom is 10 to the power minus 9 seconds for ordinary excited state. Okay, now these atoms are not coming by itself, but with the collision of one more external photon with the excited atom, they are coming back to the ground state. And this process takes place within the lifetime of the excited atom. Within the lifetime of the excited atom. That process is called stimulated emission process. Here what is happening? One more photon is colliding with the atoms, giving two photons. Which is releasing two photons. One is the induced photon, the other one is the absorbed photon, which are in the same phase, same amplitude and the same wavelength. Okay, the property number 4, the coherence property is satisfied here. amplitude, same wavelength and same phase, are in the same phase. Okay. Now again these two photons hits another two excited atoms, releases totally 4 photons. Again these four photons hits another 4 atoms in the excited state, releases totally 8 photons, and this cascade goes on so that very high intensive laser beam will be produced from the laser medium, also called as active medium.